Welcome to Mr. Thompson's math tutorial. Today we're looking at distance formula. Okay, so in the past we've learned how to find the distance between 2 points on a graph simply by using the Pythagorean theorem. So if you remember what we're doing here, we're trying to find the distance for this side right here, which is side B, and the distance for this side right here, which is side A, and then that'll allow us to find the distance right here, which is side C. Okay, so we can just simply count, right? This is the distance between this point right here and this point right here is 1, 2, 3, so that we know that our side B is equal to 3. The distance between this point right here and this point right here is 1, 2, 3. So our side A is also, in this case, equal to 3. So I would then simply plug that into the Pythagorean theorem and solve. So that would give me 3 squared plus 3 squared is equal to c squared. Okay, that's a 2. I apologize. It's not coming through very well. So this is 9 plus 9, which is equal to c squared. Well, 9 plus 9 is 18. Okay, so that's equal to c squared. And then I would take the square root of both sides here. The square root of 18, I tried to find my perfect squares. So this would be 9, which is a perfect square, times 2, which is then equal to c, because the square root of c squared is c. I can separate out my 9. 9, square root of 9, square root of 2 is c squared. The square root of 9 is 3 times 2, square root of 2. Okay, good. Now, what happens when I don't have a graph? Like, for instance, in this case right here. Well, I can still use Pythagorean theorem. In fact, this is Pythagorean theorem right here. Okay, this is essentially a modified Pythagorean theorem. Here's my a squared, and these are my b squareds. Okay, and this is really just my c right here. Okay, and I'm taking a square root. Now, the square root of the c squared has already been done here. That's why it's just the d. Okay, but the square root of this is what I'm solving. And essentially what I'm going to do is just plug things into this formula. I'm going to substitute into the formula and solve. So I'm going to call this particular point x1, and this would be my y1. This would be my x2, and this would be my y2. So I'm going to substitute those values into the formula. So here's my d, and this is equal to, my distance is equal to the square root, and I'm going to put in my two x values and then my two y values. So my first x value, my x2 is over here, it's -4. So -4, and then I'm subtracting my x1 value, which is -1. Okay, and then I'm going to square that whole thing. All right, and then I'm adding my y2. So my y2 is -5, and I'm subtracting out of that -8, and then I'm going to square that whole thing. Okay, so let's solve this. So d is equal to the big square root. Now, -4 minus -1. So I have 4 negatives, and I'm taking away 1 negative. That's going to leave me with 3 negatives squared. Okay, kind of the same idea here. I've got a -5, and I'm taking away 8 negatives from it. So I run out of negatives after 5, right? So that means I'm going to be adding positives. So that's going to leave me a 3 right here, and squared. So my distance is equal to the square root of -3 squared. Now, -3 squared is -3 times -3, which would be +9. And my 3 here, so 3 squared would be 3 times 3, which is 9. So now I'm doing the square root of 18, square root of 18, okay, which is equal to the square root of 9 times 2, which is equal to the square root of 9 times the square root of 2, which is equal to 3 square root of 2. Okay, so I'm just applying the distance formula. And you can actually see that apparently these points are the same distance as the one that was on my graph earlier. All right, let's look at another example. So I'm going to do the same thing. I'm going to define which ones are x1 and x2 and y1 and y2. So this is my x1 value. Usually just pick the first one. Okay, and this would be my x2 value. This is my y1 and y2. Okay, and I'm going to plug them into the formula. So substitute into the formula. So big square root. My x2 point is 2, and then I'm taking away 5 from that. Okay. Sorry, I did that wrong. And I've labeled this incorrectly too. So this should actually be my y1. I apologize about that. And that's my x2, y2. Okay, so I'm actually taking away 1 from this. Okay, and I'm squaring it. And then I'm adding to that my y2 minus my y1. Okay, and I'm squaring that. So let's solve this. Let's see, 2 minus 1 is 1, and then I'm squaring it. And 6 minus 2 is 4, and I'm squaring that. So then d is equal to, let's see, this 1 squared is 1, and 4 squared is 16. So d is equal to the square root of 17. Now, if I look at the factors of 17, I have 1, let's see, I have 1 and 17. This is an odd number, so I can't divide by 2. I'm looking for all the factors of 17 here. So it's an odd number, I can't divide by 2. It's not divisible by 3. It's not divisible by 4, 5, 6, 7, 8, or 9, or 10. So I found all the factors. So this is as simplified as it gets. So I'm going to leave it right there. Thank you for watching.